Hello. In the last session, we have talked about certain terminologies, or specifically we have defined mechanism and machine as well, right? So then what we have defined mechanism as, it is assemblage of resistant bodies connected by movable joints, right? So movable joints to form a closed kinematic chain, and having a purpose of transforming or transferring motion from one end to other end. Now these rigid bodies, again now we got into the terminologies, like we are calling these rigid bodies, we have seen that day, as kinematic links. So what are kinematic links? These are basically the resistant bodies, or rather these are the components or the parts of a machine. Now links need to be resistant or rigid bodies. Why? Because we need to transmit motion from one end to the other end, that we have seen why rigidity is required. Then simply we are representing link as a simple straight line, because right now we are not considering the cross sections involved. What we are required is the distance between the two joints. So it is simply the linear or the axis length between the two joints. So that is how we are representing links, simply rigid links, as simply a straight line, and these two small circles are indicating as the joints where it can form joint. So when I join another link with a link, so this is link number 1, and I join a link with link number 1, so I form a kinematic pair. And these kinematic pairs are formed with the help of kinematic joints. What are kinematic joints? Kinema means motion. That means motion must be involved, right? So, like this is one link, this is the other link. These two are joined, but they are joined with the help of a movable joint. So these are movable joints. So I am forming a pair. Now when I go on joining pairs together, so I form a kinematic chain. Now to call a chain as a kinematic chain, we need to be very specific, because any chain cannot be a kinematic chain. It can be a non-kinematic chain, it can be a redundant chain as well. That thing we have not discussed in the last session. Today I'll clarify that. Now, like I have taken a very simple example of a 4-bar chain, which is a basic kinematic chain to understand. So, like I have taken a 4-bar chain. 4-bar chain means it is having 4 links. So let us say this is link number 1, this is link number 2, this is link number 3, and this is link number 4. Now when I am going to call this as a kinematic chain, now let us say, if again today I will involve 2 more terms, like when I am giving motion to the link number 2, let us say I am giving a rotary motion to the link number 2. So this is the input, so we are giving this motion, so this is the input. So now when I move this, due to the motion of these and rigidity of the links, all the other links are going to have or execute certain motion, right? So as this is rigid, so when it is moving, it is going to push the link number 3. Fine. So that is why I am calling this input link as the driver. And my objective is to achieve the motion of link number 4. So I will call this link number 4 as the output link, or here now I will call this one as the sorry, this will be driver and this will be driven, or this is the follower. The output link is also called as the follower. Fine. So anyway, so like when this is moving, so say joint, we named this as joint A and this as joint B. So what will be the path of joint A? Of course, it will be moving about a radius of length of 2. So let us say it has moved somewhere here. So this is position A1. Now this link is rigid, so obviously this link is going to be pushed, but the B is connected to this. I name this as, let us say, C, joint C. So the motion of B about C will be at a radius of length of 4. So this will be path of B. So length AB is not going to change as it is rigid. So if I just place at A1 and mark the path of B, so I get the location of B1. So this will be the position now when this link has turned by, say, some angle theta. So the position of the link AB will be something like this, and consequently the position of link 4 or link 4 will be moved somewhere here, maybe by some angle phi. So let us say my objective was to achieve motion of link number 4. Now if you look at this chain particularly, when we are moving, see, link number 2 has executed a relative motion between 1, 2 and 3. If you see this, the angle between these two has changed. This has become more obtuse. So that means again there is a relative motion between link number 2 and link number 3. If you look at it, the configuration, this is called as the configuration, this is configuration 1, this is configuration 2. So in the configuration 2, if you see the angle between 3 and 4, it has become more acute. That means there is a relative motion between the link number 3 and the link number 4, and as 4 has moved here, then definitely there is a relative motion between the link number 4 and link number 1. So in this chain we can see, or here we can predict that all the members, all the links involved in this assembly will execute a relative motion between themselves. Such a chain will be called as a kinematic chain. So definitely when it is a kinematic chain, then all the links involved must execute a definite relative motion among themselves. Then only the chain will be called as a kinematic chain. Whereas if I take an example of, say now I take more than 4 links, if I consider, let us say I take this. So there is link number 1, link number 2, link number 3, link number 4 and link number 5 and link number 6. Now let us say if I move link number 2, so I call this as the driver or the input. I call this as driver or the input. So if I try to, or if I want to define 6 as the output link or the driven, so now when I move this one, of course this is going to push link number 3. But we cannot predict the behavior of maybe link number 5 and 6, the behavior between link number 4 and 5. So it is unpredictable. It becomes unpredictable here. So in such cases where I am unable to define the output motion, now this will not come into the category of kinematic chain. Rather, I will call this as a non-kinematic. I will call this as a non-kinematic chain. Now again, there is something called as another term we will see, the redundant chains. Now say instead of 4, I take 3 links and I join them with movable joints only. The joints which we have taken here, they are movable joints of course. So link number 1, link number 2, link number 3. But in this case, if you see, now when I want to turn the link number 2, you will see, or you will, if you imagine, try to imagine the motion. Link number 3 is, it's not possible to achieve motion for link number 3. So in this case, even though I am trying to move the link number 2, none of the links are going to execute a relative motion between themselves, though we have provided movable joints. Now such a chain will be called as a redundant chain. These are also called as structures. That again we will see when we will be studying mobility. So that is how the chains are categorized. So kinematic chain, non-kinematic chain and redundant chain. So what is a kinematic chain? A kinematic chain, of course, in a kinematic chain, all the links will have a definite relative motion between them. In case of a non-kinematic chain, the motions between the links are unpredictable. They are not definite. There might be motion, there might not be relative motion between the links possible. And redundant, then none of the links will have relative motion between them. Right? So likewise, so when we move on with this, that they also we have seen. Now the mechanism. So what is a mechanism relative to this in this study of theory of machines then? Now out of this 4, so this is a kinematic chain. We have established that a 4-bar chain is a kinematic chain. Now when I select one link, it might be link number 1, might be link number 2, link number 3 or link number 4. It can be any of the links. Out of this chain, if I select one link, for example, I am selecting link number here as a fixed link. That means this all other links will have a relative motion, or this link number 1 becomes the reference for motion of link number 2, 3 and 4. So that means when I am fixing link number 1, I am making this link number 1 as the frame of the mechanism. I am selecting link number 1 as the frame. So when one of the links of a kinematic chain is fixed or selected as a frame, it becomes a mechanism, because the input and output, they get defined. Now here 2 is the input, 4 is the output, and 3 is the connecting link between. This is called as the connecting rod or the connecting link, right? So that is how. So case can be, I can select link number 2 as the fixed one as well. So if I select, so maybe link number 3 becomes the input and link number 1 becomes the output. So this becomes the driver, this becomes the driven. It can be reversed also. This can become the driver or this can become the driven member. Likewise, I can select 3, 4 or anything, but the idea is one link must be fixed, or the absolute motion of one of the links with reference to all the other members in that chain must be 0, or that should be absolute motion should be, it should be fixed one. So then it becomes a mechanism. So if we just want to refine our definition of mechanism with respect to the keywords which we are using, we can again call mechanism as an assembly or assemblage of resistant bodies. You remember we have said assemblage of resistant bodies. Instead I'll say assemblage of kinematic links connected. So we have used this keyword, kinematic link connected by movable joints, we have said. So instead we will say kinematic joints to form a closed kinematic chain. That day we have talked about closed chain, open chain, right? So when I am joining the last link of the chain to the first link, it becomes a closed kinematic chain, or it becomes a closed chain. So it needs to be a closed kinematic chain with one link fixed. One link fixed means we have selected this as the frame. So one link fixed and having, so we said that having a purpose of transferring or transform motion. So instead it is, now we'll change the wordings in a sense, assemblage of kinematic links connected by kinematic joints to form a closed kinematic chain with one link fixed to give definite, or I'll involve another term, constrained, or it can be desired, to give definite or constrained or desired motion. So we want that motion to be constrained means what? A specific one, a definite one. So I don't want the link to move some other way. I want it to move into some specific way only. So I am constraining its motion. I am not letting it to move anywhere else. That is why we can again use the term constrained, or the motion which I desire, hence desired motion. Right? So that is how again we can redefine the definition of mechanism likewise. Fine. So now let us try to again get into, in this session again we will try to classify the terms which we have used. What are these? So number one, link. So now onwards I will not mention this to be as a kinematic link. A link means in our study it must be a kinematic term. So link. So what is a link? It is a component or part of a machine or a mechanism. So this needs to be rigid. Its intention is what? To transmit motion from one end to the other end. But so it must have the property of rigidity, then only it can transmit motion, right? So but still when we are going to classify links, now we can classify these links into rigid links, flexible links and fluid links. Now here you may ask, okay, how I can call a flexible body to be as a link, because the links are intended to be rigid, then only they can transmit motion. Now in case of rigid links, let us talk about first rigid links. Rigid links can be simple, made of materials like maybe metal, wood or something like that. So here again we can categorize the rigid links as, say, binary links, ternary links or quaternary links. What are binary links? Binary links are which can have two joints. So if this is a link, it can form two joints from here and from here to another link. So I'll call this link as a binary link. What is a ternary link? A link which can join to or form join with three links. So let us say kind of a triangular plate. So it can form three joints. So I can connect one link at this end, one at here, one at here. So this will be called as a ternary link. Or a link which can form four joints, I'll call them as quaternary links. So maybe one link here, one link here, one link here and one link here. So one single link is forming pair with four different links. So in that case I'll call this as quaternary links. Now coming to flexible links. Now we know that until and unless they are able to transmit the force, it will not be able to act as, or it will not be able to transmit motion from one end to the other. Now in case of flexible links, like if I say a belt, so one example can be belt. Now belt acts as a link unidirectional only, right? So if you see, this is one pulley and say this is pulley number 2. So this is one pulley, this is second pulley. My intention is to transmit motion from the pulley 1 to pulley 2. So what I do, I can just overlap these two links with the help of a belt, right? So when I am turning the link number, this link number 1, which is a pulley, now this is going to drag this one, right? Isn't it? So a tension will be created at the upper side. So then only it is going to turn this one. So, but if I turn it this way, then in that case it will sag, right? So it is acting unidirectionally only. So flexible links are the links which acts under tension or compression. So example can be belts, can be springs. Springs also we can use them as links because they will be acting unidirectionally, right? So belt will be acting as a link only under tension. It is going to only able to pull, right? So under tension only belt is going to act as a link. And in case of fluid links, must have heard about hydraulic systems, hydraulic braking systems, right? Pneumatic braking systems. So what can the fluid links? Can be liquids, compressed air or gases. So they can act as, see, liquids are uncompressible. So if I fill a pipe with liquid and I just push the liquid from one end of the pipe with the help of a piston, it is going to exert a force at the other end, right? So that is how the classification of fluid links. So links can be broadly classified or categorized into rigid, flexible, fluid. Rigid types can be binary, ternary, quaternary, as I have shown you the schematics. Flexible belts can act as flexible links, springs, and in case of fluids, this can be liquids or compressed airs. Similarly, now when we talk about kinematic joints, joints also can be categorized as binary, ternary, and quaternary, and maybe we can add more. So binary means when a single joint is joining two members, it is binary links. Then ternary means at a single joint when 3 links are there, at quaternary links when 4 links are forming a joint, right? So that is how the joints can be classified. That's all for this session. In the next session, we will talk about again the types of pairs. We will talk about the pairs.